All right, welcome to this explainer. Today, we're taking a super fast, honestly, kind of magical journey into a piece of tech you probably have on you literally right this very second. We're going to trace the incredibly precise, almost instantaneous path of a sound wave. We're breaking down exactly what happens between a singer's voice in a recording studio and the very moment that exact melody hits your eardrum.
Okay, let's dive into this. Have you ever actually wondered how those tiny little earphones turn just raw electricity into the music you love? I mean, think about the device currently sitting in your ears or resting on your desk. We take it completely for granted, but your earphones are essentially performing this high-speed translation, turning invisible energy into a totally immersive, emotional experience.
Phase 1. Sound becomes electricity. To really get this, we gotta start right at the source, the recording studio. So, when music is recorded, sound is converted into electrical signals. It's a process called transduction. Picture your favorite singer just belting out a note. Their vocal cords are vibrating, physically pushing the air molecules around them. But the split second those physical airwaves hit a microphone, boom, a total transformation happens. The mic catches that physical, mechanical energy and translates it into this invisible stream of electrical signals. Those signals are what ultimately travel through the wire. The music isn't moving air anymore, it's moving electricity.
Phase 2. Inside the earphone. Now, what's really interesting about this next phase is we actually have to dramatically slow down our pace. We're leaving the recording studio and zooming way in, right into the microscopic world of your earbud.
Inside every single earphone, you'll actually find a tiny, fully functioning speaker. Let's methodically break down its anatomy really quick so you can picture these pieces before we set them all into motion. There are just 3 core components you need to memorize. First up, a tiny magnet. Second, a little coil of copper wire, we call that the voice coil. And third, a super thin, flexible material called the diaphragm. These 3 simple little pieces are about to pull off an absolute masterclass in physics.
Let's look a bit closer at that third component, because it is absolutely critical. A diaphragm is a very thin speaker membrane that vibrates to push surrounding air and create sound waves. You can basically think of the diaphragm as the vital bridge in this whole operation. It's the exact boundary line where the mechanical, physical movement happening deep inside your earbud translates back into the actual moving air that will eventually reach your human ear. Phase 3, electricity creates motion. Now, let's bring back that electricity we captured in Phase 1 and introduce it to our earbud's components.
When that electrical current finally reaches and flows through the copper voice coil, it triggers a process called electromagnetic induction. Basically, it turns the coil into an electromagnet. And because this coil is sitting right next to our permanent tiny magnet, well, magnetic forces immediately take over. Here's a crazy fact for you. The magnetic field crammed inside a little earbud is often significantly stronger relative to its size than the Earth's own magnetic field. Depending on the electrical signal, the coil gets rapidly repelled by the magnet and then instantly attracted right back to it. It creates this rapid, continuous push and pull. The electricity is literally throwing that copper coil back and forth. And since that jumping copper coil is attached to our thin diaphragm, the diaphragm moves right along with it. But it's the speed of this movement that's truly mind-blowing. The diaphragm vibrates thousands of times, every single second. Just picture that in slow motion for a second. Thousands of microscopic back-and-forth movements in the blink of an eye, perfectly mirroring the original electrical signal of the music. Phase 4. Vibrations become sound. So the crucial point is transitioning these physics back into the everyday reality of you actually hearing the music.
This whole linear process is just a brilliant domino effect. Step 1, the original sound is converted to electricity at the microphone. Step 2, that current flows all the way down to the copper coil in your ear. Step 3, magnetic forces kick in, creating a rapid motion. And Step 4, that vibrating diaphragm pushes against the air molecules trapped right there between your earbud and your eardrum. What's truly phenomenal here is the sheer speed. This entire chain reaction, from physical sound to electrical signal and back to physical sound, happens with virtually zero latency. It's instantaneous.
The delivery, wired versus wireless. Let's move to this next part and see how this builds, because the way these signals reach our ears today has definitely evolved.
The physics of the tiny speaker itself, that remains exactly the same. But with wired earphones, those electrical signals travel directly through a physical cable, going straight from your device to the copper coil. Super straightforward. But wireless earbuds, they receive invisible digital signals traveling through the air using Bluetooth technology.
Because it's a digital signal, your wireless earbud actually has to perform an extra lightning-fast conversion step. It translates that digital code back into an analog electrical current before it can trigger the magnet and push the diaphragm. Pretty amazing, right?
So the next time you press play, just remember what is physically happening right inside your ears. Your earphones are not just little pieces of plastic. They are tiny, incredibly precise speakers performing thousands of invisible magnetic vibrations every single second, just to recreate a sound. It's a microscopic symphony of physics and engineering sitting right in your pocket. Knowing the incredible science of how all this works, how will that change how you listen to your favorite song today?